worry, I'll be back soon. But for now that you've taken notes on 8.1 on the worksheet provided, did you check your solutions already? I hope so. It's on Schoology.com. But now, we're going to go into 8.2, because that's the most important. How do you graph reciprocal functions, which represent inverse relations that you just noticed, okay? That you studied on 8.1. Now, we're going to go into part 1 and graph the reciprocal functions. Now, what I'm going to show you right now is the reciprocal function family, which can be found in your book as well. So if you can't see this that well, don't worry, it's in your books, okay? Now, key concept, the reciprocal function family. It's pretty much like this. You know how everyone has an STD? That's right, everyone has an STD. Well, the parent function is also there with every function that we've talked about, right? Well, there's a parent function here, y equals 1 over x. So y equals 1 over x is your big mama. But you know what? X can't equal what? I heard you, 0. X can't equal 0 because we can't divide by 0, right? All right. Now, what if this is always going to be the big mama, the big parent, okay? Now, all the transformations will take place with this guy here. So, for example, if you have an absolute value of a greater than 1, what's going to happen? It's going to stretch this guy, right? Now, I'm going to show you what this graph looks like later, okay? We're going to graph it, but we just know that if we multiply this guy by an a somehow, we're going to stretch this guy. Now, if your absolute value of a is greater than 0 but less than 1, so it's a fractional value, right? But less than 1 but greater than 0, then you know that it's going to be like this, right? So any of these values, it's going to stretch or shrink based on whatever the a value is. Reflection if a is less than 0, so if a is negative, then you know it's going to be a reflection about the x-axis, right? Because we're changing the x value, right? Every x value has been swapped to a negative of that, okay? Now, translation. So you're going to have to know this guy right here. Write this really big in your notes books, okay? Y is equal to 1 over x minus h plus k. Wait a second. The Hong Kong is back. That's right. The Hong Kong is going to mean something to us later. Something really big. But obviously, again, we have to say x cannot equal h. Because if x is equal to h, what happens? Think about it. You got it. It's a 0. That's right, okay? So you can't have that, right? All right. Now, I'm going to tell you a secret with this right here, okay? Oh, but let's put it all together, okay? Oh, they're going to mention it here, but I'm going to actually put it all together. So you have your STD form. Your parent is what? Let's recap everything. Y equals 1 over x, where x can't equal 0. But your STD form, your standard, is going to be y equals a, because you know you're going to have to apply the a, right? You're going to have to apply your a. It's a stretch or a shrink. X minus h plus k, where x cannot equal your h. But there's something more, guys. You know how x can't equal h? That means your vertical asymptote is x equals h, because that's the first value that x cannot be. So therefore, there's a vertical as, because you know that any graph like x equals 2 is going to be a vertical line up and down, okay? Now, that also tells us something else, and horizontal as, okay? Make sure you guys write this out, so just in case, rewind the video too. Vertical asymptote, horizontal asymptote. Horizontal as is this. You're going to learn this better later, but for now, just know that this k tells us that y is k, which means k is the first value that it cannot go, it cannot touch. And I'll explain that a little bit later. There's a lot more to this. But for now, just know that the k will tell us the horizontal as, okay? All right, let's go on to page 2 of your notes. Okay, so we're going to go on to the first part, but let's actually graph for now, okay? Let's graph. Let's graph something like this. Y equals 1 over x, which is our parent, right? Okay, so what do? You're right. We just start plugging in numbers, right? We're used to this. Let's go from -3, -2, -1, 0, 1, 2, 3. We're very good at this. And when we actually solve the y values, we get 1 over -3, 1 over -2, -1. Oh, what happens here? You're right. It cannot be undefined. 1 over 1, 1 over 2, right? And 1 over 3, okay? Sorry about the different way of writing a fraction there. Okay, so let's graph this. Hey, don't think anything of it. Oh, I know you notice something. You notice here x cannot equal 0. That means our vertical ass is at x equals 0. You know what we should do? We should actually just go ahead and put a dotted line on our x equals 0 line. That's going to tell us, oh, it can't go beyond this. Okay? But you know something's going to happen to the right of this and to the left of the vertical ass. So let's plug in our points. At -3, it's -1/3. Oh, it's very small, so I'm going to put a dot there. At -2, it's -1/2. It's a little bit greater, but it's this way. At -1, it's -1. Okay. So like right here maybe, okay? At 0, it's undefined, so I'm going to go 1, 1. Okay. At 2, it's 1/2. 3, it's 1/3. So what do you think is happening? If I plug in 1/2, think about what happens. If I plug in 1/2 here, 1/2 is 2. So I'm going to put a 2 here. Oh, what about if I put a 1/3? If I put 1/1/3, that means it's going to be a 3. So you see what's happening, right? This graph goes like this. It gets closer and closer to the asymptote. It's trying to reach it, but what's happening? It's going to go, okay? It's going to go this way. And you know that no matter what, it can't go below this, right? Because you can't turn it negative, right? How about here? Same thing happens here, guys. If you don't believe me, go ahead and put it onto Desmos or your calculators, okay? It's going to go like that, okay? That's going to be your y is equal to 1/x graph, okay? Okay. Now, okay? What happens? So that's the classic STD. That's your standard, that's your parent graph, okay? Y equals 1/x. And that's going to be what you base everything on. So now I'll have to make you think a little bit, right? Oh, so we forgot to write something, guys. If we had the vertical asymptote here, do you remember that we have the standard form, y equals a/x minus h plus k? We said that x minus h represents the vertical asymptote, in which case it's this guy for us. Now let's always do the horizontal as too, because inverse functions, reciprocal functions will always have a vertical and a horizontal, unless maybe not, but most times they do. So k, what's our k here? It's nada, so y is equal to 0. So we should also indicate our horizontal as here. It can never be this either. It just gets closer and closer to this. So we should write both of our asses, okay? Now I want you to also think about some other cases. So for example, let's actually verify that graph, okay? So when I put this into your calculators, here's what I got. I got this graph here. The vertical ass and horizontal ass do not show, and here's our values, undefined always, okay? But what about if I do -1/x? I mean, think about what happens to each of these values, right? Think about what happens. Think about what happens, okay? Think about what happens to your x and y when you have this, right? You're right, all the x values, all the y values, what used to be negative becomes positive, right? And it becomes negative here. So you're right. Let's graph it just onto here. The asymptotes are the same, so the vertical ass is still x equals 0. Horizontal ass is still y equals 0. So we still have our asses here, okay, and here. I'm just trying to put it a little away from the 0 actually, so you can see it better, okay? And if you were to graph that, look, -2 is a half now. -2 is a half now, right? -1 is a 1 now. So you see what's happening. If I put a -3, think about what happens. If I put a -3, it becomes 1/3. So you see that this graph is going to go like this. I'll try to use a different marker, okay, so you can see it. This graph is going to go like this, getting closer to this vertical asymptote, and then this gets closer to the horizontal asymptote this way. And this side, look at it, 0, 0. Oh, 0, 0, I'm sorry. Oh, I know you were freaking out. It's undefined still, right? Undefined at 0, 0. Sorry about that. Please note that. And 1, -1, 1, -1. Oh, it's going down. 2, -1/2. So it's going to be like this. So you can see that this side is going to go this way, and this guy goes this way. And this blue is y equals -1/x. Oh, so it's been reflected. If you change every x values to the opposite, that means it's been reflected by the y-axis. You see how this guy, what used to be the parent, now flipped over and it's on this side. This guy used to be the parent, flipped over, so now it's on this side, okay? All right, so now you can see where we're going with this, right? Now we're going to apply some transformations. So think about now, what if I did y equals 5/x? Ooh, What if I did negative 5 over x? Think about that, right? It's been stretched, right? So every y value now, it used to be 1 over x, now becomes 5 over x. Oh, so you're right. You can kind of play around in Desmos. It's a transformation of this original function. Okay, so now let's do part 2 with all the transformations, okay?